Alrighty. Let's get started. Let's get this show on the road, shall we? So this talk is getting started or with Kubernetes journey with EKS Blueprints for Terraform and Waypoint. Uh, so first, let me introduce everybody to Joyce, who wants to optimize her team's productivity. Joyce is the program manager at her company. And the company is actually moving to Kubernetes, and they're going to be hosting that on EKS. So she is looking for ways to really make her team self-reliable and ways to make sure that once she moves to Kubernetes, she gets environments that where she can deploy quickly and she can continue to deliver value for the customers in a way that is um, good to meet everybody's needs. So at the end of the day, she just wants to empower her team to control their own future. However, she has one issue, and it's a big one. While Kubernetes is great and it has a lot of features and it's extremely powerful, um, nobody tells you how to put it together. So it's not just a matter of setting up Kubernetes and you're good to go, right? In fact, you have to set up observability, you have to set up security and persistent, and all these other items that are peripheral to Kubernetes itself, but crucial for you to be able to manage your application. Um, and in fact, if we look at the list of official projects, quote unquote, that the Cloud Native Foundation has in their website, and the Cloud Native Foundation, for those that don't know, is the governing body for Kubernetes. They list over 140 official projects. So how do you put all these projects together in a way that you can quickly deploy clusters and so that you can deploy applications into those clusters so that our consumers and customers can actually take care of them? So I'm the guide on this journey. So this is what we're going to be exploring, how to speed up this process of moving to Kubernetes and actually managing your clusters, and also how to set up your infrastructure so that you can actually deploy and um, manage your applications in the cluster quickly and easily. My name is Juan Peredo. I'm a cloud application architect at AWS. Uh, but at the end of the day, I'm really an architect, a consultant, a developer, and everything in between. I've been in all those roles, and I just like technology and solving problems. So what's going to be our recipe for success today? Well, we have to solve her two problems, right? First of all, cluster management. How can we set up all those clusters easily and quickly? And for that, we're going to use EKS Blueprints for Terraform. This is going to significantly simplify and enhance the creation and management of those EKS clusters running Kubernetes. And the other one is application management. We want to enhance and uh, allow our teams to easily deploy to Kubernetes without having to have a big steep curve in terms of learning time and learning effort. And for that, we're going to use HashiCorp Waypoint. So let's start with EKS Blueprints for Terraform. What? So EKS Blueprints for Terraform allows to create well-architected Kubernetes clusters in minutes, not days. And what do I mean by well-architected Kubernetes cluster? It basically means a high availability cluster where you can comfortably run your applications and make sure that if something happens or for some reason one of your nodes goes down, you can be rest assured that that's going to come back up, and your customers are not going to see any stoppage. And that's what you see on the picture on the right. So you basically have your Kubernetes cluster running in three availability zones. with all the nodes and all the infrastructure that you expect from a Kubernetes cluster. And not only that, it also has a number of services that you could also include into your Kubernetes cluster. So, for example, we could install in there. We can install Prometheus and Grafana for observability. We could have a Vault installed for secret management, for example. And all this can be done with EKS Blueprints for Terraform, and it will all be done with infrastructure as code. And that's important because the last thing we want to do is going into a console and creating all those things manually every time. So if today I have one cluster that's my development cluster, and tomorrow I want to create a second test cluster, I can run the same infrastructure as code, and it will create the exact same cluster that will be identical to the first one. And all this is done with Terraform, which is one of the industry standards to build an infrastructure as code, and an extremely powerful tool. And it's extremely extensible, so we have add-ons for multiple applications. I'll talk about that a little more. And you can even integrate it with CI/CD tools like Argo CD to keep your services, the services that you're installing in your cluster, that will allow you things to get set up like observability. You can manage them through Argo CD, which can be easily integrated with EKS Blueprints for Terraform. And I mentioned how the EKS Blueprints for Terraform is actually built with Terraform. In fact, it's in the name, right? But that allows people coming into a blueprint repository and seeing blueprint code to be instantly familiar if they're familiar with Terraform. Right? They can jump right in, and that will allow them to create these EKS clusters in a much more in a faster way, right? Than if they had to learn everything from scratch on how to set up a Kubernetes cluster. Plus, it will allow you to make changes over time to that cluster. The other tool that is significant for blueprints is Helm. And if you're not familiar with Helm, it's a chart management tool. You can think about it as NPM for Node.js or pip for Python. But instead of deploying libraries, it's deploying Kubernetes services and applications. And one of the things that makes EKS Blueprints for Terraform really cool, in my opinion, is that they take away a lot of the complexity by using same defaults, right? So there's a lot of roles and policies that you have to set up when you're creating a normal Kubernetes cluster. But when you're running EKS blueprints, it does take some of the decisions away from you, but it also gives you a way to override those decisions and make your own. And I mentioned that it's extensible, right? There's a numerous number of add-ons that are currently available. They are free to use to install a number of tools directly into your cluster. And installing something like a load balancer controller, so you can have a load balancer fronting your application, becomes as easy as having a one-liner in your code. And that's what we have here on the left. This is all we need to do to enable the creation of a load balancer on your cluster. So enable AWS load balancer controller equals true. Now, what would you have to do, just to put in context, right? What would you have to do if you wanted to do this by yourself and create it from scratch? Well, you would have to create policies, you have to create roles, you have to attach it to Kubernetes, you have to make sure that everything is talk between your cluster and the AWS console is interacting properly. And then you could launch a controller yourself. You have to install it. And that's a couple of pages worth of work that you're saving just by doing that one line of code. And it's important to note that even though I'm showing here the one-liner, you can still fully customize all the add-ons that you're adding to your cluster. Because we're using Helm, we use the same values chart or values file to customize these charts and these services that we're installing. Like, for example, if we wanted to configure the way that Prometheus is getting installed into the cluster, we could add a values file for Prometheus, pass it to the chart, and Helm will deploy it, just like if you were doing it from your terminal in your machine. So let's take a look at what it would be like to deploy something with Terraform for EKS with the blueprints. So I'm going to come here, and then this is actually what the code would look like to deploy an EKS blueprints cluster. The first part of it is pretty standard. This is just the AWS VPC module that's standard. So all I'm doing here is, first of all, just creating my VPC, creating all the necessary subnets so I can then go ahead and create my cluster. So I'm going to skip through this really quickly because there's nothing new there. If you've ever used Terraform, you probably created your VPC. That's what's expected. Once we get to the blueprints portion of the code, that's when it starts getting interesting. Right? I'm going to tell it what VPC I want to use. Then I'm going to give it instructions on how I want to set up my cluster. And in this case, I'm going to tell Kubernetes I want to set up some node groups so I can have between 3 and 5 nodes running in that cluster. Now, in this case, I'm using managed nodes. I can create unmanaged nodes, or I can create even Fargate, which is our serverless offering for EKS. And we could set those up just as easy as creating these node groups here. Once we've set up our nodes, the other thing that we want to make sure that we have is we want to make sure that we have access to that cluster. And for that, we have the concept of teams, right? So we can create a platform team. This is the operations people that will have full access to the cluster so that they can do all the administrative duties. And in this particular case, I'm just giving myself that role. I'm making myself part of that group. But if I wanted to have multiple people, I could. And then I would have full access to that cluster. And they would too. Then I can create application teams. And application teams are, for example, if you had in your environment, you had a team that's building your invoice platform and another one that's creating your ordering platform. You would at the very least, if not creating them into clusters, you want at very least to have them in different namespaces. And that's what this is doing here. I'm creating 2 namespaces so that my 2 teams that are working on these 2 different projects, or in this case, in 2 different environments. So I want to create my development environment team and my test team. And for each one of them, it's going to create a cluster, a namespace in our cluster. And I can also provide it with a quota for each one of those namespaces. And what is that quota, right? So I'm going to come here into the variables folder of file, and here we have the requests that I'm going to put and the limits I'm going to put on that particular namespace, right? So if I don't want, the dev team to go over 3 CPUs of usage in that cluster, I'm going to put those limits here. Or I can put the limits on memory. I can do all these things to ensure that one team is not going to override what the other team can do. So it's not going to take over the whole cluster. And I can do the same thing for my team, for my testing. So now I have my cluster. I have access. I've given access to certain people to that cluster. Some of them are part of the team. Some of them are part of the administrator group. Now I'm going to actually start installing add-ons. And like we said before, right? Each one of these add-ons and services usually takes a while to install and get right and get going. But with add-ons, it's as simple as giving the one-liner to each one of these things. So if I want to set up a new CNI, or I want to set up an EBS driver so I can get storage, it's pretty straightforward to do. And we can actually also install more complicated tools into our cluster. So for example, Istio, which can be interesting to install and configure sometimes. We can install it and all in several of its components, rather in a simple and easy way. But I mentioned that we can configure this, right? So what if we don't want the way we're installing it out of the gate, right? So that's when we can start passing configurations. So in this case, we can tell it the name for the release name or the exact version that we want to install. And we can also pass a values file. And I'll show you what a values file looks like, but it's basically just like a Helm values file. So those few lines of code are just there to install Istio and set it all up. We can also install observability. So observability is crucial in any Kubernetes cluster. So we want to have metric server, FluentBit to get our logs, Prometheus for example, for our metrics. But as I mentioned before, I can pass, in this case for FluentBit, I want to configure the way it's going to get installed. So I'm going to pass to it a YAML file. If I look at that YAML file, it looks exactly like any other YAML file that's provided to Helm chart, which is great because a lot of the documentation that's provided by vendors, they give you the exact parameters that you need to pass in order to configure the chart. So this works exactly the same way. And we're installing a number of things here. So Prometheus, Grafana. Then the next thing I want to just quickly mention is that we can also enable Argo CD. Argo CD will make sure that whatever services we have in our repo, we can also install them in our cluster, and it will constantly make sure that our repo is in sync with what's in our cluster. And there's two ways that Argo CD can be configured with to work in EKS. And those two ways are, you can have Terraform install all the charts, and then Argo just keep track of applications. So additional applications that you want installed into your cluster. Or you can have Terraform only install the necessary roles and policies, and then Argo CD actually manage your Prometheus and your Grafana implementations, and it's going to be looking at those repositories for you and making sure that they're all set up properly. And we can even install things like for security in HashiCorp. We can install things like Calico. And that's the basics of it. You can see how the pattern here is a pattern of let's just set up, enable the add-on, and then let's pass some configuration, which makes it very, very simple. Okay, and that's the way you would. That's the typical way a blueprints file would look, and that can be used to create your cluster. Then when we're ready to create a cluster, just like any other Terraform application, you do Terraform apply, and within a few minutes, you have your cluster with everything installed and ready to go. So what does that mean for us? So that means that we have actually solved one of Joyce's problems, cluster management. How can we quickly and efficiently create not just one environment, but multiple, right? The next challenge is application management, right? So how do we deploy the applications into Kubernetes in a way that's easy for developers to use and reduces their time to learn and get started. And for that, we're going to use HashiCorp Waypoint. Now, HashiCorp Waypoint is actually allows you to abstract the complexity of building and deploying these applications. So uh, once it's set up and you've configured it, deploying a new application is as easy as going waypoint up, which is what we see here on the right-hand side or the left-hand side, right? Waypoint up. And that will instruct Waypoint to go through a series of instructions to deploy the application for you. The way I usually think about it, at least for me, is like thinking of Docker Compose up on steroids, right? Waypoint up can deploy to Kubernetes. You can deploy to a number of platforms with very little need to configuration by the developer once it's being configured by the operation people. So we can do things like automatically containerize and deploy the applications, so you don't have to worry about creating your own Docker file, for example, or your own Docker containers. And just as important, it allows operations to standardize how applications are getting deployed in an organization, right? Because the developer, all the developer has to do is waypoint up and make sure that their configuration file is set up properly. And it's a very simple and straightforward process that can be used throughout the organization. So as I was saying, right, the goal of Waypoint is to make it as easy as possible for the dev team to deploy applications, and also make sure that it's easy to configure for operations so that they can configure the way applications must be deployed in a secure and maintainable way. And the way it does that is by the use of a waypoint file, and it's waypoint.hcl, the default name for it. And we can see one example here on the left-hand side. And basically what it's doing here is taking an application using build packs to convert it into a Docker file, and then pushing it into a registry, which in this case is Docker. Right? And it's giving it a tag just to make sure that it gets deployed properly. Or I guess, yeah, deploy properly to the registry. After that, it's using Helm to actually deploy it to the cluster. So anybody that's used Terraform or the Vault that's used HCL language before, this is the same language, so it'll feel right at home. And you can use this waypoint file and the waypoint application to deploy to a number of targets, right? Not just Kubernetes. You can go to container services. You can even deploy to as Lambda, so you can make waypoint part of your serverless deployment workflow. And all this gives you, and all this can be done through the waypoint CLI. But at the end of the day, anything you deploy with Waypoint will show up in the UI, the Waypoint UI, which is a great place to see all your deployments in one place under one single pane of glass. So what does it look? What is the process to deploy to EKS using Waypoint? Well, it's a four-step process. First of all, you have to set up a cluster, right? Now, hopefully after our previous discussion, you'll see that, well, easy way to do that is using blueprints for Terraform. But at the end of the day, you need to set up a cluster. Then you create your waypoint ACL file, which is what we are seeing here on the right. And at the end of the day, it's a very simple process. And well, as it can get more complex depending on what you're trying to do with your application. But at the end of the day, you have the same stages. So you have a build stage where you're in this case, once again, using build packs to deploy your container to ECR, build and deploy the container to ECR. Then you deploy to Kubernetes. And finally, you release your application, which means you're telling Kubernetes to create a load balancer on a particular port. So um, so that would be what a waypoint at a high level could look like. Once you've created your waypoint HCL file, you can then install and init the waypoint server. This waypoint server will actually run on your cluster, and it will create some pods that will be listening for the commands to be coming from the terminal. And at that point, you just run waypoint up, and you're good to go. And that will start the deployment process. So now we've seen two things that make Joy's life so much better, right? We have seen cluster management, application management, and deployment. So we basically given Joyce all the tools necessary to empower her team. On the one side, we have blueprints for Terraform. On the other one, we have Waypoint, and she can easily create fully featured Kubernetes cluster, deploy applications, and focus on delivering value to the customer, and not just on dealing with IT problems. And what are the key takeaways from this, right? On the one side, we have blueprints for Terraform, which allows to, which is Terraform native. It allows you to create clusters with batteries included out of the gate. And it's simple and effective. It will create your clusters you will in minutes, and you can be able to get going to using that cluster. On the other side, we have Waypoint, right? So Waypoint provides us a powerful abstraction on the way we have to deploy applications. It's very developer friendly, and it strives to make things as simple as possible. And that is also extensible. So we talked about Kubernetes in this particular conversation, but at the end of the day, it can be used for deploying anything else. Now, if you're interested in learning more about any of these solutions, you are welcome to visit these. These are the main websites for each one of these items. And I don't know if we have some time for questions.